Audio Jungle. Audio Jungle.
Right. So if you see the tail contribution, check everybody. In LSS, longitudinal static stability, what was the tail contribution? If you see the equation, that equation was CM CZ for the tail, means pitching moment coefficient about CZ for the tail, and we had calculated eta T, right? We had VH, and then it was CLT. This was the formula, correct? And if you see the criteria, that also we had discussed criteria for the tail. If you see that tail is what contributing positively or negatively, so what you will do, you just calculate dm dou cm cz t with respect to the dou cl t. So what you will get, you will get minus of eta t into vh, correct? And if you see eta t and vh, what was the eta c eta t? Eta t was the tail efficiency. It is also called tail efficiency, correct? If you remember, it was tail efficiency. And tail efficiency also, mathematically, tail efficiency, mathematically, what was the value of the tail efficiency? If somebody remind, tail efficiency was the dynamic pressure over the tail divided by the reference uh, dynamic pressure. And similarly, there was the vh, and if you remember, vh was the tail volume, was tail volume. And if you see the tail volume, so it was defined mathematically. I'm just saying, okay, this is very important to know, because sometimes everything will be there but you would not be able to apply. Like they will be given st, they will be given lt. St for tail surface area, lt for the arm length from cg to aerodynamic center of the tail. All those things I have discussed, so I believe that you all remember this. Okay, so vt, that is the tail volume divided by the reference volume. And if you remember, tail volume was the st, that surface area of the tail, into the arm length lt divided by the volume, that is the s for the surface of the wing, wing area, surface area of the wing, into the chord of the wing. This was the value. So if you see, I mean, both magnitude wise, both if you check, doesn't matter, it is this what it is called, tail efficiency. So magnitude wise, qt by q infinity, it will be positive only. And similarly, this, because this is what dynamic pressure, half rho v square, and this is what volume, so this will also be positive. So if you see both positive, positive, so already it will be positive, so there will be negative sign already there. So negative into positive, you will get negative. So this symbol, you are basically getting negative value here, that is the dou cm cg by dou clt. And if you see the meaning of this negative value, it's nothing but less than 0, correct? So already I have told you the stability criteria. What was the stability criteria? That dou cm cg, it doesn't matter it is for tail or it is wing, but dou cm cg by dou cl, or also dou cm cg by dou alpha, both that must be negative for the stability. So the overall thing is what, that tail will always contribution will be the contribution of the tail always will be positive. Positive contribution means it will always stabilize the aircraft, so the stability contribution will be positive. Negative contribution means it will destabilize the aircraft. Don't relate with this positive negative, that dou cm cg by dou clt, that is the different thing. Dou cm cg by dou clt, it's a slope. Slope is negative, that means that contribution, because negative slope is what desirable. So if you see that dou cm cg by dou clt, you are getting negative, so doesn't matter that contribution is negative. No, that contribution of the tail in LSS will be positive. Positive contribution means it is going to stabilize the aircraft. So it will stabilize the aircraft, that's all. Destabilize the aircraft, that's all. Okay. And if they ask the contribution, so contribution of the tail for the LSS will always be positive, means it will stabilize the aircraft. That means the positive. Hope you all getting my point, correct? Still, if somebody have any doubt, you please can ask to me. Okay, now moving ahead, here we'll have a next step. I'm just going to see, this was done last class. Okay, so now just going to next another step for this particular so CMCG, please check it. CMCG of the tail is nothing but minus of eta t into VH into CLT. This is the formula till now you have seen. Okay, also you know that the slope the slope of the wing also you had seen, and now we are going to discuss the slope of tail as well. So what was the slope of wing? If you remember, slope of wing, if you remember, it was dou CLW divided by, okay, dou alpha W. This was the slope of the wing, which was AW. Generally we'll be talking A. This was the slope of wing. Similarly, we will write slope of tail. So what will be the slope of tail? The same, you can take dou CLT divided by dou alpha T, and that will nothing but AT. Always. So if A is there, then only it's a slope of wing. If AT is there, that means it's a tail slope. That should be remember. Okay, that should be remember this both formula. It's very special actually, right? Now we'll be finding the angle of attack for the tail. That already we had seen in my partial derivation. Last class I had shown for the tail contribution. That was the partial derivation. The full scale derivation I had not given, but at least idea and few steps I had given, and the diagram also I had given. So for tail angle of attack, for tail angle of attack is nothing but alpha t. It was given. You see, I had shown the diagram and I had explained there that alpha t, which is the angle of attack for the tail, was the total alpha, which was the angle of attack of the wing, minus the downwash angle epsilon, minus the it was the incidence angle. That already I have discussed to you. Okay, so if you check here, because you are going to calculate the AT, that is nothing but dou CLT by dou alpha T. So basically, first of all, you should know alpha T. So alpha T is alpha W minus of epsilon minus of IT. That already I have given this, and all the parameter epsilon and IT I had shown in the diagram, and I told you epsilon is the downwash angle, IT is the incidence angle, that you know very well, correct? Now moving to the next here, because I am interested in the complete form of the CMCG of the tail. So what I will do here, check it. As you know, as you know that AT, what is the AT now? AT is nothing but the slope of the tail. It is defined as dou CLT by dou alpha T. Just now I have defined. Check it, this one. So use this. What will be the here? Because see, you are going to talk the 80, so that also you can write because it's a change, so small change, so that also you can write C alpha CLT divided by alpha T, like that also you can write. So what will be the CLT? So CLT is nothing but AT into alpha T. This much value if you write, that is sufficient. Sometimes 2CLT by 2 alpha T, that change. So for the change, reference value will be given to you. So that time you can write CLT 2 minus CLT 1 divided by alpha T 2 minus alpha T 1. But if reference is not given, or if there is no reference, so directly CLT by alpha T you can write, and ultimately you will get CLT is equal to AT into alpha T, right? You just placed in your main final equation of the CMCG for the tail. So CMCG for the tail, it was minus eta T, VH and CLT. This is the value. Now CLT you can replace by minus eta T, VH and CLT is nothing but AT alpha T. Correct? That also you can write minus of eta T, VH, AT and alpha T. Just now you have seen alpha W minus epsilon minus I. This is the complete equation of the CMCGT. I hope you all are agree with this, right? Because this is the main and very powerful equation. You please remember this, okay? Please remember this. This is the one of the finest equation. With the help of this also you can solve many problems, okay? So what you got? Pitching moment, I will write here properly. Pitching moment coefficient about CZ, okay, of tail. So sorry, should be for tail, not of. For tail wing, correct? So you see the expression, it's nothing but CMCZ minus eta t BH. First I will be written CLT, all the format I will write, minus eta t, maybe VH CLT, instead of CLT they have given AT and alpha t, that also you can write. Maybe it is also given eta t VH AT, as is it is alpha t is nothing but alpha W minus epsilon minus. So this will be the main equation. You please make a note of this. This is nothing but for the tail. You everybody please write this, all the formula. So whatever in what format they are asking, it's your job to remember all the format, okay? I have given to you. This is the one of the finest equations. So that's the reason I always used to tell, if one time derivation is sufficient, okay, any book you can take and you just see the one time derivation, rest you need to remember the formula, because that formula will be used directly for your numerical in your gate exam, okay? So this is the one final equation. This is the contribution of the tail. I have shown you that contribution of the tail always it will be stabilizing the aircraft, so the contribution will be positive always, okay? That you had seen. Now, always one more parameters I just want to tell you, that this epsilon, whatever epsilon you have, epsilon is nothing but downwash angle. Okay, what is the epsilon? It's nothing but downwash angle. But this mathematically, it is the mathematical empirical formula. Also, you can say this epsilon is nothing but it's epsilon naught plus dou epsilon by dou alpha. Okay, in terms of the alpha W. So downwash angle when the wing body is what combined. Okay, that time when wing body, because downwash angle you will get. I told you that that time also when I had shown the tail contribution. So there will be the downwash, and because of the downwash, that CLT lift generated by the tail will be changing. You see the formula also. CLT is what depending on the downwash angle, right? So actually this CLT change because of the downwash, and this downwash always because of the main wing. Okay. So when the wing body is what combined, so that time what will be the downwash angle? That will be nothing but epsilon is equal to epsilon naught dou epsilon by dou alpha. Okay, this is the one empirical value. Okay, one empirical value you can say, it is tested in wind tunnel. Uh, and then this is the wind tunnel experiment data basically. Okay, so that epsilon is the contribution of epsilon naught and dou epsilon by dou alpha. Okay, you need to remember this, right? The value will be given to you. This is the wind tunnel data. I will write here, otherwise you may. So this is nothing to do. Okay, this value will be given to you always. So this is the wind tunnel data. Wind tunnel data. It's a always you will get through the experiment one. Value will be given to you. You now just check it. This CMCG you just replace this. So automatically, what is the CMCG you have? CMCG for the tail, it will be minus eta t VH. Okay, and eta t VH into, you know, CLT you have. So instead of CLT at AT into alpha t, so AT into alpha t. So alpha t, as I have shown you, alpha W minus epsilon minus IT. This is the value, correct? If you keep epsilon which is nothing but epsilon by dou alpha. Okay, you just place this value, so what you will get here, that is the one important. So you just do steps. MCZ, it's nothing but, check it now everybody. So what you will get, you see it. So it's nothing but, I would say, minus of eta t. Please check it. Okay, you just do few steps, so you will get it. Eta t vh at and just open the bracket alpha w, correct. And alpha w, this epsilon, because alpha w, you just take the common. Alpha w is here, alpha w is here, so you will take the common, so it will have a 1 minus. Please see this steps. Okay, it's easy only. 2 epsilon by 2 alpha after taking alpha w common. Then again, because here we have a minus sign already, and this is also, epsilon is also minus, so you just check it, minus minus plus, so you can put plus sign here. Again, you will take all the value inside, so it's nothing but eta t. Okay, vh into this at, and this at will be with epsilon naught and it, because dou epsilon by dou alpha already taken outside. So here in bracket you will have epsilon naught plus it. You please check the steps. Okay, you do it. So this is the one final expression you got here. Okay. See, everybody will solve the problem also, so you will understood this, huh? How that data will be given to you for the calculation, you will understand. But remember, this is the tail contribution. I hope you you all got this. Okay, check it now. Also, you should know that if sometimes they will be asking the this value also, I one more steps I just want to give. If they are asking cmcg, okay, or cmcgt, or they can ask cm not t, and that I hope you understood. This means that uh, alpha w, alpha w is what, 0, or cl is 0, so that time this part will be 0 only. You will have eta t bh, okay, at epsilon naught plus it. This value you need to remember. You see, this should be positive, that I had given to you. This is the second criteria. Second criteria. What was the second criteria? If you remember, cm naught should be positive. Cm naught means pitching moment coefficient about cz, when the lift produced by the, or lift coefficient of the wing, or lift generated by the wing, that lift coefficient must be 0, or the angle of attack of the wing must be 0. So that time, what is the pitching moment coefficient? That is called as just cm naught. I hope you all remember. See, this was the data I had given, if you remember this graph. If you see, this was cmcg, this was the cl, or you can say alpha. So basically this was the slope. So you had seen that, okay, dou cmcg by dou alpha is what, negative. This is the first criteria for stability. And second criteria also I had given to you, that this value, check what is the value here. You can say cl is equal to 0, or alpha is equal to 0, correct. So here, if you see it, then what you will get? You will get that the value of CMCG, where the alpha W is 0 or CLW is 0. So this will be now, CMCG will be replaced by CM naught. This you had seen, correct? So based on this, you got that this CM naught will be always positive. This was the second criteria for the stability. For stability, there was two criteria, criteria 1 and criteria 2. In both, if you see, that till is what fulfilling. Check it. So That's the reason tail is always a positive contribution, or you can say tail is always a positive contributor for the longitudinal static stability. I hope you understood now, right? Now coming to the tail efficiency and all that, last class only I had given the value and data also. You remember it. Eta T is generally, as I have told you, it's a tail efficiency factor. So tail eta T, whatever it is, it is nothing but 0.65 to 0.95. Okay, if it is, this is the range actually. If they are, but if nothing is given, you consider one as well. Okay, and you know that higher tail efficiency factor, higher is the longitudinal static stability. How you would know? You see the formula, check it, eta T. So if eta T is what, this is also one important. I just want to give the note. Otherwise, so you always remember this. Okay, eta T is nothing but it's a tail efficiency. What is this tail efficiency factor? And that tail efficiency also you had seen, it is Qt by Q infinity. That means 1 by 2 rho T Vt square divided by 1 by 2 rho infinity and Q infinity square. Right? This was the value. So this tail efficiency factor, as per the formula, if you see, it is clear now that if tail efficiency is higher the value of tail efficiency, there will be the longitudinal static stability will be higher. Or LSS means longitudinal static stability, and vice versa. This is one very important they can ask to you. Okay, so remember it. Always remember the tail efficiency. Always it will be affected by the what you can say. See the formula only. Okay, so you will understand. One eta t is what, qt by q infinity. That means 1 by 2 rho t vt square, and rho infinity v infinity square. It's a, suppose rho infinity v infinity square. You can say it's a reference dynamic pressure. Okay, now the, if you see the eta t, how it can change. So there are three factors to check the eta t, how it can change, how it can vary. Because what is the one conclusion we got, that eta t should be very high. If eta t is high, then longitudinal static stability will be high. So you should know what are the affecting factor. So you can say that uh, eta t is eta t affected by eta t affected by, please make a note, eta t affected by the location of tail. Okay, first very important, location of tail. I should say location of tail affected by location of tail. One very important. Second, it is also affected by the power plant. Affected by power plant. Power plant means that engine. Two types of engine we have now, pusher type and propeller type. Propeller type means when the blades or that propeller is what placed ahead to the, or in front. See, these two types of engine we have, pusher and propeller. So obviously it will be depending on the it depends on the pusher or propeller. Check it. So power plant, I will show the diagram so you will understand. See, few engines, that propeller will be here, and few engines propeller will be here. So this is what propeller type, and this is the pusher type. So because of that also, that eta t will be changing. Effect of PowerPoint. Always remember. And I don't know how many of you have gone through the propeller theory. So there is the propeller slip stream also. So that also depends location of the tail plane with respect to wing, and this is the location of tail with respect to wing. With respect to wing, and location of tail plane with respect to propeller slip stream also. So only you just remember location of the tail and power plant, that is sufficient. So eta t also changes once you are using a propeller type or pusher type engine, number one, and the location of tail with respect to wing also, because few the fighter aircraft Concorde or uh, another also, especially Concorde, if you see that tail is what placed ahead to the, I mean, it is in front only that tail has been placed. Generally, tail is what? It's just behind, right? After the main wing. But if you see the Concorde fighter aircraft, so that tail is what? Ahead to the main wing. So that means it is the location of the tail with respect to the wing. That you also you can have some uh, can say kind of study, but don't go in that detail. They are not going to ask very deep and detailed things, but at least you should know how that tail efficiency is what going to change. That is the main motive to tell you. Otherwise, just for your interest, you can learn Concorde aircraft and all, and just go through it. You see when the tail is what placed ahead to the main engine, then what is happening, ahead to the main wing, then what is happening, and when the tail is what behind placed behind the main wing, then what is happening, and what are changes, stability point of view. It's your interest, you can go through it. Now, as also we have seen, this is the one factor, that is the tail efficiency. Second very important factor that I that also I have told you, sorry, VH. If you see it, how this VH is what affecting the LSS. So VH is nothing but basically ST into LT divided by S into C. Correct? You all know very well that LT is nothing but arm length. I told you already. LT is nothing but arm length. Arm length. Correct? ST is nothing but tail surface area. Okay. S and C is what basically the reference area or reference area and chord length, which is generally reference. Our main concentration on tail only. If you see for the tail, if you check, if the ST is what high, I mean the large area you are using, large area, okay, and that time your VH, which is nothing but the tail volume ratio will be high. ST is high means tail volume area, VH is what high. If VH is high, that means stability will be increasing, correct? So it is uh, it is more stabilizing the aircraft now when the ST is, so you can say LSS will be high. LSS means longitudinal static speed. Correct? Similarly, if LT is nothing but, I told you, LT is nothing but arm length. That is the distance between the aerodynamic center of the tail to the CG of the aircraft. So if arm length is what high, so CLT is high means VH is high. If VH is large, high means large. VH is large, then LSS will be more and more. That means longitudinal static stability will be more. That's the things you should, I mean, realize just writing the formula, connect with all those. Because nowadays, very one liner theory question they are asking. Okay, so you should remember all those things, correct? They may ask to you arm length is what now two times of the initial, then what stability of the aircraft, LSS, longitudinal stability of the aircraft, increasing, decreasing, half, double, something like that. So you please go through it, just realize by your own right formula, try to connect each and everything, you will get your answer, right? Anyway, so coming to the next is nothing but the fuselage contribution. Correct? Till now, main wing contribution I have told you, and that what it is called tail contribution also I have told you just now. I have finished. Now we'll be talking fuselage contribution. Correct? Third one. Okay. To LSS. longitudinal stability. This is for longitudinal stability. If you see the component, check it. I'll show you. So generally, this part is nothing but the fuselage. Okay. So even though it is destabilizing the aircraft, okay, CMF, if I will write the pitching moment coefficient of the fuselage about CG, so because CG is also existing here, think about it, you will get it, okay, very easy only. You see somewhere CG is what here, somewhere CG is what here only. So if you write the moment about the CG for the fuselage, so it's very small actually. Even though if you ask the particular value, then it will be destabilizing the aircraft. Okay. But generally will be considered because the amount of the moment, the destabilizing moment, it is very less. The coefficient of moment will also be very less. So because the very less value, you can neglect it. So you must say that pitching moment coefficient from the fuselage is generally neglected. I hope you understood why, because you see this section where I have marked that 1 and 2, this region itself a fuselage, and here CG is also existing here. So if you take the moment about the CG of the fuselage, whatever the forces generated by the fuselage, even though it is not producing any lift, but very small, because it's that the whole section of the aircraft, whole component, whole, you know, uh, doesn't matter it is the engine shape and size, I mean outer surface I'm talking, or tail, or main wing, or nacelles of the engine aircraft, engine of the aircraft, everything is what designed as aerodynamic shape. Hence less and less drag should be there, and if it is possible it can generate lift. That is the aerodynamic shape. Okay, but at least drag should be very less, and it should produce lift. So even though that fuselage that also have the shape, okay, in that shape, so that it can reduce the drag, but if little bit also, because it's a floating, so that lift is what generating. So that lift force into the distance between CG and that aerodynamic center, so it will be very less. That moment produced by that, so it's very less, even though that contribution is what negative, because if you talk the magnitude, so little bit value you will get it, but that will be the destabilizing the aircraft. So in general we'll be talking that there is no contribution. So that's the reason I have written CMF is equal to 0, but if you see in many books it is written it will be destabilizing the aircraft. At least in longitudinal it is neglected, but if you talk lateral and directional, so it will be destabilizing the aircraft. You see it, okay, later on. So that contribution I'm considering that LSS, there is no contribution. No contribution in longitudinal static. It is not going to stabilize, it is not going to destabilize. That's the mean of it. Okay, right. Remember it, this part. Coming to the main equation now. So, what is the total pitching moment about the CG? Is the total pitching moment about the CG? Say it now. Total pitching moment about CG. Huh? See it, everybody. Main wing, useless, and tail wing. Correct? So, talking to the main wing, it's nothing but CMCG of the wing. Okay. CMCG of fuselage and CMCG of tail. But just now I have shown you this part we can neglect. This one we can neglect here. Check it. This one we can neglect. So your CM of CMCG of the aircraft. For the aircraft only I will write CMCG. Okay, so CMCG of the aircraft is nothing but CMCG of the main wing plus CMCG of L. All right, CMCG of L. Good. Now you see the main equation what you are getting now. So I will write CMCG of the main wing. If you remember CMAC, teaching moment coefficient about aerodynamic center, into CLW, that lip coefficient of the wing, main wing, minus H minus HAC. To remember or remind the previous classes, you will get this was the main wing, eta T PH into CLT. Just now you have seen. This is nothing but main wing. This is nothing but tail. This contribution you need to remember. Okay, everybody, I'm just asking. So total, if you see the component, okay, for the aircraft, I will elaborate this equation. So you final equation you check CMCG. Okay, for the aircraft, what you will get? Check it first, which is nothing but CMAC. Please check it. CMAC plus CLW H minus HAC. Okay, now eta TBS CLT that I have given to you and just broken in, I think, two component. You see it, the main equation. There it is. See that, see this part here. This part, no, I'm talking. No, not this. I think here, check it. In two parts it is broken now. See everybody, this part, huh? Two parts of the tail also is there. If you please check it, this two component I just want to add here for the so what you will get, you will have eta T BH, it's nothing but AT alpha W 1 minus dou epsilon dou alpha by dou alpha plus it's nothing but eta T BH AT epsilon plus I. This was the check. This is the main equation. You should remember. You should remember. Check. This is the complete longitudinal stability LSS equation. See, 1, 1, 2, 3. Three components we have. So that's the reason I always used to tell this is the master equation of LSS, longitudinal static stability. This is for the complete aircraft here. This is for the aircraft. This is for the aircraft. So see, this is the main wing and this is what tail, two contribution. Here basically main wing and tail wing. It is written, and if you see the whole format, also you can write the angle of attack. So CLW also you can write AW into alpha W. It's your choice. So this is the main equation, correct? This is the main equation. So again, I will rewrite this. I will rewrite this. We can write in terms of the uh, slope. We can write this. Okay, slope. So how you will write in terms of slope? Again, it's very easy only. Check it. Check it. You will get. I'll write. See, another different format you should know, so that whenever in what format it is required, you directly use it. So you know that I have written this in CLW format. So what will be the another format you can write in terms of the angle of attack? I can give in terms of angle of attack. So what you will do? Check it. You will write here CMCG of aircraft, instead of the CLW, you can write AW into alpha W. So CMAC plus CLW is there. So CLW you can write AW into alpha W. There should not be any confusion. AW is the slope of wing, alpha W is the angle of attack of the wing. And here, what you can write, check it. In the bracket, what you have? You have H minus HAC. Then you can write eta T minus, as it is. You can write this eta T minus BH, okay, AT alpha W. Please concentrate here. This should be very important, and it should be known only. Eta T VH IT. Check it. Yeah. What you will write? Now check it. This complete equation. So what another format? CMAC plus. I have AW instead of AW, because AW is nothing but what? Slope of wing. I told you in previous lecture also, AW also you can write as A only. So A and alpha W also you can write, this is the angle of attack of wing. So alpha W you can write only alpha, that also sufficient. A into alpha W, or your choice what you want to write. But generally alpha, if it is alpha T, tail angle of attack, they will write alpha T. If it is angle of attack, that means it is, they are talking about the wing. All right, so here, and you know that if you talk about the wing angle of attack or wing slope, so it is generally for the airplane. It is generally for the airplane. So I will write in this format. You please check. CMCG of the airplane. Please concentrate. Okay. So it is CMAC plus A alpha. A alpha. As you have seen, alpha is nothing but alpha W here. So if you have taken common for all, check, because here AW into alpha W you are going to take common. Take it. So see, alpha W is here as well. You have alpha W here, and here also we have alpha. In the second part, you don't take common second part, at least first and this. Till this you can take. I will write here so you will understand. So A alpha W. Take it. So one big bracket, and here it will be nothing but H minus HAC minus. Check everybody. Eta T BH. Okay. Alpha W you have taken common, but A is already here. A also you have taken common, but A we do not have. You can say this is AW again. So AW alpha W you have taken. Alpha W is there, but AW is not there. So now it will be divided. So you can say it's nothing but AT by AW. You check it. And in bracket what you have, 1 minus, this bracket is what? Eta T BH AT, right. So for airplane, what you will write? You can say CMCG CMAC instead of AW, because whatever the angle of attack of the wing will be the angle of attack of the aircraft or airplane. So better you, instead of AW alpha W, you can write only A alpha. I hope you understood my point. Correct. So what you will have? H minus HAC eta T BH AT by A, that is the slope, 1 minus dou epsilon by dou alpha Okay, bracket is closed now. Plus eta t vh at epsilon naught plus epsilon it. Check. This is another format of the, and it's the same only. But I have written in terms of slope. If they have given slope of the tail and slope of the wing, so you use this one. Sometimes they will give the ratio slope of tail and slope of wing. So intentionally they are asking write this formula, use this formula. So that's the reason I'm writing in different formats. Okay, it's the same only. So don't take so much burden. At least remember one equation, and you will get. No need to go for each and every term. Correct. Now you see it. I'll show the contribution of all components here. So I will show the CMCG plot to you. CMCG versus CL or curve. So here I will show all the things like wing contribution, tail contribution, power plant contribution, or you can say it's nothing but the fuselage contribution. That also I will show you. Okay. So check it now. Here the main equation I have written to you. Now I'll show one graph to you. It's nothing but CMCG. It's alpha. Correct? Please concentrate there. So you will understand. What is the criteria I have told you? First criteria. First criteria. What is the first criteria? Dou CMCG by, okay, by dou alpha must be negative. That is the first criteria. What is the second criteria? The second criteria is nothing but CM naught should be positive. This two I have told you. CM naught means it's a CMCG value. CM naught is nothing but CMCG value only when CL is equal to 0, when alpha is equal to, okay. Right. Coming to the main graph, this is very important, I would say. Please concentrate. So check it now. See here, first the main contributor is nothing but tail, which is always producing the first uh, by default. It is a stabilizer. It is uh, contributing a positive stability. Positive stability means it is going to stabilize the aircraft. So to stabilize the aircraft, two criteria, which is nothing but dou CMCG by dou CL, or dou CMCG by dou alpha should be negative and CM naught should be positive. And I had shown you for the tail, it was satisfying both. So this first one is nothing but tail. To make it stabilize, that slope should be negative. So see, the slope is what? Negative one. Number one. Number two, will be talking the another component, which is nothing but the main wing. So I had shown you that single main wing always a destabilizing component. That contribution of the main wing always a negative. It will be destabilizing the aircraft. I have given a proper derivation. You please check it. So this is nothing but main wing. This is nothing but main wing. So see, by the slopes, seeing the slope only, you can say this is the positive slope. So if positive slope is there, it means it is destabilizing the aircraft. See, it is negative slope. So always remember, negative slope means it is stabilizing the aircraft. Correct? Criteria, you please check it. Criteria, these all the criteria for what? For LSS, longitudinal static stability. So main wing is what? Destabilizing the aircraft. Obviously, fuselage, I have told you, even though it is very less, but yes, that contribution point of view, if you check, it is destabilizing the aircraft. So this is also, which is nothing but fuselage. This is nothing but fuselage. 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 So this is also a positive slope, so destabilizing component for the longitudinal static stability, but it is negligible, very less. Don't check the magnitude, slope, and all here, because this diagram is not exactly magnitude wise. It is not correct. That's that much of fuselage slope. If you check, it is highly destabilizing component, but it is not like that. That I told you CMF value will be very less because the CG and the fuselage, it is almost very close. And the CG is what lying on fuselage somewhere. So if you see the moment coefficient value, it's very less. Magnitude wise, it is less only. So, but nature wise, it is destabilizing. I have told you that time also. Now talk about the power plant. So power plant itself, if you see, was pusher type airplane. It is the pusher type airplane, then it will be stabilizing component. But propeller type aircraft, because nowadays we are having a propeller type, because in pusher type there are some disadvantages also. So but nowadays we are using propeller type, means the engine propeller is what placed ahead to the main wing, just like a propeller engine you have seen. So that type of power plant will be destabilizing. Okay, but pusher type, if you see, it is destabilizing. So generally we are using propeller type, so the propeller type airplane will be the destabilizing component. So I should say that is nothing but power plant. But here I would say power plant means propeller type. It is destabilizing the aircraft. Okay, right. Then the overall, if you check, because this tail itself, अगर आप टेल का चेक करोगे, that slope, if you magnitude wise, if you check the slope of the tail, which is the positive contribution for the aircraft, which is the negative slope actually. So this negative slope will be more than the effect wise, if you check, it is more than others three means that power plant, fuselage, and main wing. So the overall effect, it will give the positive contribution because of the tail only. So that you can think like this: the tail magnitude is nothing but 30, and rest other are suppose 10 to 5. So 10 to 5 is what? 17. So still 30 is what larger value compared to 17. So that is the main point. So if you check the overall effect for the aircraft, if you talk about the airplane, so airplane will be stabilizing condition, then only it is flying, right? So now if you talk about the full airplane, the whole airplane, if you talk, then the whole airplane will be here only. See, this will be the whole airplane. So that whole airplane will have a negative slope. That means it is LSS, longitudinally static stable condition. Okay, so the whole. So this is the graph. I must tell you, I had given a graph for the vibration also, under damped, over damped, critical damped. I had given the comparison point of view. I had given the graph last class. I'm talking last year. I had given for the theory of failure, where I had given von Mises, maximum principle, uh, maximum strain energy, all those. So graph I had given. Question they had asked there, comparison of other in the single graph. So this is also very desirable for GATE exam, I would say, because last time they had asked vibration, under damping, over damping, critical damping, as well as that Prisca theory, von Mises theory, all those things they had asked. Maybe this time they can ask. So I'm not sure, but yes, such type of question nowadays, if I follow the pattern, then I must say 60-70% chances, like, okay, question they can ask from the graph like this. This is one graph where they can ask question. They will simple give graph, and they will say 1, 2, 3, 4 numbering they will give to you, and they will ask that which one is what is statically stable, longitudinal static stable component. Like that they can ask to you. If you see the uh, positive contribution, so the positive contribution is what? Tail only. Because of tail only, the whole aircraft or whole airplane is what? longitudinally static stable. That is my point here. I hope you everybody here now agree with this. Correct? Again, now based on this, because I have told you that CMCG, when it will be zero, when that value of the alpha, value of alpha, or you can say CL, will be zero. So here, see, at this point, what is the value of CL? It should be zero. If value of CL is equal zero, so the alpha value will also be zero. Correct? So if value of alpha is what zero here, so now I will find the in CM naught value, which is for the complete airplane. Now I'm earlier, whatever I had calculated CM naught or something, it was for the maybe for the main wing, or maybe it was for the tail. But now what we are talking for the complete airplane. So separately, I will calculate CM naught for the complete airplane, where main wing and tail contribution will be there. Okay, so I will. This is question they had asked in your gate exam as well. So you just write down CM naught calculation. What I have should write CM naught calculation. Please write down this CM naught calculation. So what is the CM naught? In word, it is called as a pitching moment coefficient. Pitching moment coefficient about CG at zero lift coefficient. Okay, please remember this. Or zero lift coefficient, or at zero lift one. That also correct. Zero lift. Okay. So now I would say to calculate this. Okay, calculate this CM naught, we have to keep in the formula, we have to keep CL is equal to 0 if somewhere there. We have to keep the alpha is equal to 0. Obviously, lift is equal to 0. These are the parameter we have to keep 0. Then we'll be calculating the CM naught. So at this value, CMCG considered or called as CM naught. I hope this is very sufficient, huh? Because writing definition is not good thing. Technically, you should understand. So hope everybody understood what is the CM naught. Huh? In the graph, where is the CM naught? See, in the graph, where is the CM naught? Check it. Everybody, this value is nothing but CM naught. Because here, this is nothing but the value of CMCG, where CL is equal to 0. Correct? So CL is equal to 0. So if you talk about the whole aircraft, okay, if you talk about the whole aircraft or whole airplane, so this is let me correct this, because this is the tail. So your whole aircraft is what, till this only. Okay, so you just, this is the for the complete airplane. So this is nothing but CM naught. Please check it. This is nothing but CM naught. Okay, where the contribution of the main wing as well as uh, tail will be there. So I will write the formula. That is the main important. See this equation now. Check it, or this equation. Please check CMCG for the airplane. This is the CMCG for the airplane, right? Now here only, here only. No? Anyway, okay, we will लिख सकते. CMCG of the airplane. If you make alpha is equal to 0, so the second, because how many component we have? First component, this is the second, and this is the third. Okay? Third means from here to here. Second means from here to here. And this is the first. So check where alpha is there or CL is there. Alpha, because this is nothing but what? This is nothing but CL, I told you. Correct? So CL or alpha you are getting in the second component. Any equation you can check. So only first and third will be there, right? Only first and third will be there. So if you calculate and write the value of CM naught, which is very special, and in gate exam they had asked. So I would say it's nothing but first component, which is the CM of about aerodynamic center, pitching moment coefficient about aerodynamic center, plus this value eta t bh at tail slope in bracket epsilon naught plus angle of incidence for the. Please remember this. Okay, this had asked in your exam, so you should know this value. Okay, and we'll solve the problem also, so you will understand. Not one time, multiple time question has been asked based on this. So this is very serious, okay, concern. You should remember anyhow. It, this formula is very. This is one. All right. So now definition wise also it is very clear what is the CM naught. So you can see it's a value of CMCG at zero lift coefficient, right? At zero lift coefficient, correct. Now moving ahead, we'll be talking about the neutral point and all that also I have to discuss. Okay, that also I have to discuss here only. One by one I will talk. Now, first I will uh, calculate the slope. Okay, for the complete airplane. Till now I have given the pitching moment coefficient. So uh, now, as I have told you, I'm just going to write the pitching moment coefficient about CZ, and I'm just going to write the same formula in terms of the slope of the pitching moment coefficient. Better to say. Okay. So I should say slope of pitching moment coefficient about CZ of airplane. This is the for the complete airplane. Till now, whatever the slope we had written, it was maybe it was for main wing or it was for tail. But now we are going to write for the complete airplane. So what you will do? So first you write the complete formula CMCG for the airplane. Check it. Airplane AP. I'm just writing. So try to understand this. The formula is nothing but you have written already. So directly I'm just going to write CMAC A alpha, okay, in bracket I would say it is nothing but H minus HAC, correct, minus of eta T BH. This is the slope AT by A, 1 minus rho epsilon rho alpha, correct, plus third component that you also remember in the same format, first component, second component, and third component, like that you remember, okay, eta T VH AT in bracket epsilon naught plus. This is the formula you have, right? Now I just want the slope here. So if you are writing the slope for the pitching moment, what you will do? Simply you will take the derivation, first derivative with respect to any CL or alpha, because you have written the formula in terms of alpha. So better you write in terms of the uh, differentiate with respect to alpha only. So you will have, please check it now. It's very special. Those CMC of the airplane with respect to alpha. This is for the airplane. What value you are going to write here? See, CMAC, which is that is the definition of the aerodynamic center also. What is the definition of aerodynamic center? That derivative of the derivative of the moment coefficient about aerodynamic center is always zero. Correct. So if you write the dou CMAC, because moment about aerodynamic center is always constant. So if you take derivative, then it will be zero. So this part will be gone. Agree with me, right? This part will be gone. So I would say directly alpha already have gone. So you can write A, this second part. In the bracket, it will have a H minus HAC. Correct. Minus of eta T BH AT by A 1 minus rho epsilon by rho alpha. Okay. And the third, see somewhere alpha is there. No, it is not there. Okay, alpha means I'm talking about the airplane angle. So we do not have any air. Et is the tail slope. So tail angle of attack will come. But if you see directly, we do not have any alpha in third component. So that part also zero. Right. So the whole expression, if you check, this is the expression which is very powerful. Which is very powerful. You see it. Right. So anyway, now if you talk about the value, this dou-CM-CG. Somebody asked to you some. What is this dou-CM-CG by dou alpha? This slope. So this slope, slope of CM-CG about slope of pitching moment coefficient about aerodynamic center with respect to angle of attack will also be called as pitch stiffness. Please remember what it is called. Pitch stiff. This is also called pitch stiffness. Okay. Right. So now this is the one formula in terms of the slope. Here you have written. Now because we have written the slope, so definitely we need to talk the neutral point here. What is the neutral point or what is the trim point that we have to discuss? So now I'll give the another heading which is called a neutral point, because later on we have to calculate the location of neutral point. Not one time, multiple time. In examination they had asked, several exam they had asked neutral point. Find out the neutral point. And if you go systematic, then it is very easy. Otherwise, it will be very difficult to find. So because till now we have gone properly, step by step, systematically we have gone. So let me complete the neutral point as well here. So I'll give heading neutral point. This is the very important point here for the airplane. Neutral point. I will define it later on, but here mathematically I will explain you what is the neutral. So the neutral point, it is first of all, it is denoted by HN. Neutral point, it is denoted by H. Okay. Now you had seen two dimension already. I have taken H was the location of the CG from the leading edge. HAC was there in the formula, was the location of aerodynamic center from the leading edge. Now we are going to talk HN, that is the neutral point location from the leading edge. So everywhere, everything, whatever we are writing, that location or distance, we are measuring from the leading edge of the airplane. Correct? Now of the wing. Anyway, to check it, see this. Two things I want to discuss. We had seen the graph, right? If you check with the graph also, we have to go, so it will be more clear to you, because photographic memory, you heard about it. It's very, I mean, whatever you are listening, maybe it will not be impactful, but whatever you are seeing, graphics will be very clear and it will be long lasting. Better I will show with the graph, so it will be. Take it. CMCG you had seen, this is the CMCG, and here you had seen L. Correct? Now if I say the slope is what this, correct? Multiple time I have shown this is the slope, right? If you say this is what slope, check it, everybody. If this is what the slope, and this slope is nothing but whatever it is forming, it's nothing but dou CM CG by dou alpha, and that is negative. Okay. And here if you come, yes, let. Okay, I'll talk here only. So what is the dou CMCG by dou alpha at this point? And you say dou CMCG by dou alpha will, it will. What is the mean of it? Simple. See the pitching moment coefficient about CG, that time will be constant. Then only if you differentiate about differentiate with angle of attack, then only it becomes zero. Try to connect it. What I'm saying, you just try to connect it. Suppose this is the airplane. Maybe somewhere this is the point. I would say this is the point for the complete airplane. See, concentrate A and B. Somewhere this is what CG. Please check it, na, everybody. So if I say that this is what CG, okay, this is what the CG location. So whatever the pitching moment coefficient about the CG, CMCG, if I say it is constant, what is the mean of it? If the pitching moment coefficient about CG is what constant, then that means it's a neutral condition. Why? I mean, why it is why it is called neutral? Because see, there is the moment about CZ, whatever it is there, it is not varying. So if it is not varying, so there is no pitch up or pitch down. If it is varying about CZ, means sometimes suppose 200 Newton meter, sometimes 20 Newton meter, sometimes 250 Newton meter. So sometimes positive or negative based on that. So if moment is what varying, then it means there is the motion, and that is nothing but about the lateral axis, and it will be the pitch up or pitch down. If moment is what changing, so pitch up, pitch down, pitch up, pitch down, it will be continuous. If moment is varying, I'm talking. If moment is not varying, if moment is what constant, think it will be neutral. It is not going to up, it is not going to down. I hope you are getting my point. So the neutral point is the point where the pitching moment coefficient about CZ is what constant. You please remember this. Or another word, this is also mathematically they are going to ask in your exam. Or another word, also you can say, as with the graph here I have shown you, that dou CMCZ by dou alpha will be 0. That is the, because see, if it is constant, then if you take derivative, it must be 0. So anything, I mean, both are correct, okay? Both are correct. That pitching moment about CZ must be constant, that is the neutral point, or the slope, okay, dou CMCG by dou alpha is equal to 0 at neutral point, that also correct. I have told you, suppose now in terms and yes, this point in technically this point is called as a trim point. What it is called? Trim point. Trim point itself called as a trim condition, you might have heard, no? Trim condition. Trim condition means basically that moment which is not going to change about this, that means a neutral condition, that is called trim point. So that pilot will be in rest mode, no need to hold any sticks or something. That aircraft is what now trim condition, पता होगा आपको, that now it is like one stick is what uh, that pilot can leave it, and will be on autopilot mode, sometimes you might have heard. So trim condition, trim point is stable now. That's the mean of it. Correct. So they are asking because you have now seen that pilot will be relaxed and all. I have told you. So that means it is very important point. So everyone should know what is the neutral point. That everybody should know the formula how to calculate, and obviously they should calculate also for the all type of aircraft. For all condition they will have the formulation, they easily can calculate, and they may say okay, this is the neutral point. They will go and they will fix it. Correct. So how will calculate? It is now very clear, very easy now for you. Neutral point, if you want, then whatever the slope you have calculated here, see, you have written slope, do CMCG by make it 0. Simple. You just make it 0, because I told you that it is all about the CZ. Maybe check it. It will be very clear to you. See, this is the CZ. Here your moment is what constant. Now tell me at CMCZ, CMCZ at A, it will be constant? No. CMCZ at E constant? No. Then it will be constant when it is uh, at CZ only. Let me the contradiction. CM I should say. Or anyway, I will give another point. This is point C. Be very clear so that it will be very important to know. So I can say CMCZ, pitching moment coefficient about CG, because you have calculated. So at A constant, no, it is not. At B it is constant, no, it is not constant. But if you say CMCG at C is constant, yes, it is. So if it is constant at point C, okay, then this point will be called as a neutral point. So even though CMCG pitched about CG at point A, you are correct, but here you are saying, if you are here, if you check, that moment is what changing condition. It is not constant at point A. So the thing is what, the CG location you are varying. Okay, the CG location you are varying from C to A. or C to B. I mean, this is the range. A to B, it is moving. CG is what moving. CG variation you had seen in the main wing. I told you that time also that CG is what changing, that CG is also responsible for the stability of the aircraft, correct? Longitudinal static stability of the aircraft. So what should be the maximum value? That time Girish has asked this question. And what will be the uh, ahead and whatever the forward or behind? This is the forward value and this is the behind value. So this value is what fixed for the each and every aircraft. That beyond this A, that CG cannot uh, lie, and beyond this B, that CG cannot lie. That CG will vary from A to B or B to A. In between, anywhere it can be there. Okay. So CG will change, but it should not go beyond A. It should not go beyond B. It should lie in between A and B. That is my point actually. So that's the reason sometimes the suppose the aircraft is what now unstable, or so that time it is happening sometimes. Okay. So they may have like they may ask, "Oh, this will be the one disturbance came and some very critical case I'm talking, so the passenger will move maybe ahead or maybe behind to fix the CG, okay, to make it stable or to fix the CG. You might have seen some Hollywood movie, and also passenger will move ahead or behind, so that that CG can shift at one point where it can achieve a neutral point, so that the aircraft can come to the stable condition, something like this. Okay, you might have heard, or even though you google or you just read some books, get such type of examples. Okay, so the CG is what changing, huh? So what is the CG? You have seen that H was the CG. I had shown you HAC was the aerodynamic center location. It was the aerodynamic center. H was the CG from the leading edge. You see your formula, even though in this formula itself, check this H is nothing but the CG location, and this was the aerodynamic center. Correct. So now I would say the value of H becomes HN when it is achieved the neutral point. I hope it is very clear. Huh? If H is what exactly uh, we'll be talking the CG, then it is H. But this CG is what changing, and it is changing from A to B. Somewhere it will achieve its neutral point where the moment becomes constant, moment coefficient becomes constant. So it will be clear that this point is nothing but the neutral point, because here a moment becomes constant. So that neutral point uh, location will be denoted by HN. So HN is nothing but actually it is H, that is the CG location. Okay, and that also big difference, because the definition wise, if you see the neutral points and aerodynamic center, at aerodynamic center also you have seen that moment was constant, and at neutral point also we are having the constant moment. Now somebody asks to you, what is the difference? It's very easy. Aerodynamic center, you will always talk for the wing of the aircraft. You will find aerodynamic center along the length of chord, which is for the wing only. But if you talk the broad label, that is the airplane or aircraft, then that aerodynamic center will be just like a neutral. So neutral point is always defined one parameter which is for the complete aircraft. And aerodynamic center is also the same mathematical model. Mathematical model in the sense same. The moment coefficient will be constant about CG, about aerodynamic center, and about the neutral point. But aerodynamic center is what for one only wing, and neutral point is what defined for the complete aircraft. That is the difference only. Otherwise, everything will be same, right? Anyway, I'm much more curious about calculating that neutral point. So let us see that formula. So calculation I will write here, calculation of, because whole things now you understood. Now we will complete this. So calculation of neutral point, NP, neutral point, which is nothing but HN. This is very important for your gate exam. If I'm saying gate exam, so obviously it's nothing but any PSU exam, okay, FCAT exam for aeronautics, DGCA exam, huh? Is PSU, that it's DRDO or ISRO. So remember it. Huh? Now I'll calculate it. How you will calculate? So first you should calculate dose GMC by dou alpha for the airplane. Already you have written for the airplane. What is the value? Check it, everybody. It is nothing but a. I have given to you. Please check your notes. HAC. Okay. Right. Minus eta t ph at by a. Correct. Now I want neutral point. So what I will do? I will say this dou CMCG by dou alpha must be 0, and I would say it will be 0 when h will be denoted by hn. Okay, so I will keep this, check it, I'll keep this value is equal to 0 as per definition. This will be as it is. It will be only h will be replaced by hn minus hac eta t ph, everything as it is. Okay, at by a 1 minus dou epsilon by, check it. Now, can I say that hn, you please solve it? Take outside a slope. This slope a will be 0 now. Huh? If you check it, ultimately what value you will get? Can I say hn, if you take opposite, so hac will be positive that time. So hac and eta t will also be positive. This part I can take positive. Eta t ph at by a 1 minus dou ln by. This is there very very important. Okay, you please. So it's a for your suggestion to you. Please remember this. Huh? This is the location of node for the complete. So this is the location. Correct. There should not be any confusion now. So denoted by HN, and always now question will be asked to you, what is the slope at slope of moment coefficient at neutral point? So you have to say 0. Here I have given all those things. So all the information here I have given. Just remember. So this is nothing but slope. So slope will be 0. At neutral point, slope will be 0. Slope of what? Slope of moment coefficient. Slope of moment coefficient must be, huh? Correct. Anyway, now now we'll talk the whole stability criteria for the complete airplane, because earlier we had seen it was only main wing. Now we'll have a whole aircraft. So obviously if we have a whole aircraft, then we'll talk about the neutral. Okay, and we'll see the variation about the neutral point and CG. Okay, and then we'll find the static margin. All right.